A tool we may use to find the current amplitude, the voltage amplitude, and the phase of the circuit is called the Phasor diagram. Okay, so I just want to teach you about the Phasor diagram first, and then later on, so just consider about the circuits of the R, L, and the C. What is the Phasor diagram? I guess that you have learned the idea of the Phasor diagram from the physics 1 already. The idea is we just want to write down the current and the potential difference as vectors, okay, as vectors. When we talk about the vectors, it has amplitude or the magnitude, right? And it has the direction, okay? So in this case, we just want to write down the amplitude of the current or the amplitude of the delta V, right, as the magnitude of the vectors. And we just want to write down the phase of the current and the phase of the delta V as the direction of the vector in the counterclockwise to the horizontal axis here, okay? And then if we have the psi function, we need to project this psi function on the vertical axis. If we have the cosine function, we need to project the cosine function on the horizontal axis. Okay, for example, let's look at this one. Okay, if I have the I equal to the I naught and then times the psi theta, right? I equal to I naught and then times the psi theta. So we say that the I naught is going to be the magnitude of the vector, and then direction is going to be the theta in the counterclockwise to the horizontal axis, right? So we have this axis, the vertical one and the horizontal one. So let's say that this vector, okay, so let's say this vector, it will have the length of the magnitude equal to the I naught. So let's say the length of this vector equal to the I naught here. And then direction right to the counterclockwise to the horizontal axis to be the theta. So it means that this angle is just equal to the theta. Okay. So the meaning of this sentence is, if we just want to find the psi function of this vector, we need to project this vector on the vertical axis. Okay, so if we project this vector on the vertical axis, it's gonna look like this length. Okay, this length. Let me move to the advanced a little bit. Okay, so this length is going to be equal to the I naught and what? Okay, if we break the vector out of the angle, you can get the psi theta, right? So we can get the I naught and then times the psi theta here, okay, which is this one. So that's why we say that for the psi function, we need to project the vector on the vertical axis, so you can get the psi function. And then how about the cosine function? Then we need to project the vector on the horizontal axis, right? So it's going to be this one. So okay, if we break the vector into the angle theta, you can get the cosine theta here, and that's it. Okay, so we say that for the cosine function, we can get the projection on the horizontal axis. So that's going to be the idea how to get the sine or to the cosine. But I would recommend that if you just want to combine the 2 or the 3 vectors, right, or more, so the easiest way to do is to convert everything to the sine function, because this will be the simplest that we can do. So sometimes you can have the negative sine function, right, the negative sine theta here. So we can use this identity. So the negative sine theta equal to the sine of the negative theta. So the negative theta just means that it's going to go to the clockwise direction instead of the counterclockwise direction. Or we have the cosine theta, right? We can just write out the cosine theta in the terms of the sine theta and then plus the pi over 2. Or if we have the negative cosine theta, we can just write down as the sine of the theta minus the pi over 2. Okay. So this will be the identity that we always use in this chapter. So I recommend that change everything to the sine function. Okay, just change everything to the sine function. And the other trick that we can use is, so you can see that, for example, this one, right? We have this sine omega t, and we have the sine omega t plus the phi. So it means that initially the phase of the current and the potential difference just start from the omega t. Okay, and then later on, some of them we have the phase difference by the phi here. So then I would recommend that we just make the omega t equal to the 0. Okay, so initially we just make the omega t equal to 0, and then for the final answer we just plug in the omega t back to, the final function. Okay, so let's consider this one. I have the current I, right, depending on the time t, equal to the I naught times the sine of the omega t plus the pi over 6. So now you can see that if we just want to write down this one as the vector, right, so the I naught here is going to be the magnitude of the vector, and we make the omega t equal to the 0. Okay, for the simplicity, just make it equal to the 0, and it means that we have the pi over 6 to be the direction of the vector. So in this case, we can just write out the vector as this one. Okay, so if we have this direction to be the pi over 6, and then the length of this vector is going to be equal to the I naught. Okay, simple. Okay, another example. If I have the current I depending on the times t, right, equal to the I naught times the cosine of the omega t. Again, so now we have the cosine function. We need to convert the cosine function to be the sine function first. So we can use this identity, the cosine theta, right, equal to the sine theta and then plus the pi over 2. Then in this case, we can just write down the it equal to the I naught and then times the sine of the theta plus pi half. So now this theta is just equal to the omega t. So we have the sine of the omega t and then plus the pi half here. We just make the omega t equal to 0. Okay, the I naught is going to be the magnitude of the vector, and then the pi over 2 is going to be the direction of the vector in the counterclockwise direction. So in this case, you can have the vector to be this one, right, because the pi over 2 is just 90 degrees. Okay, and this will be the I naught, which is the length or the magnitude of the vector. Okay, so now let's consider the R circuit, the L circuit, and the C circuit separately.